On to calculating the y-intercept. So let's just recap what the y-intercept is. So it's where the graph intersects the y-axis. So if we look at the graph on the right-hand side, you can see that on my axes I've actually drawn an equation. So let's just say it's y equals x plus 4. So you can see here that the graph actually intersects the y-axis when y is equal to 4. Another feature you can notice using this example is that x is always equal to 0 at the y-intercept. So anywhere along this particular axis here, x is always equal to 0. And that's really important to remember, because if you can see where a graph intersects the y-axis, you know immediately that the x value will be 0. So how do we calculate the y-intercept? So we've got a couple of different methods. One, we can use a table of values to find where x is equal to 0. So remember, our table of values is like the one that I've just identified. So that's just an example of one. So obviously we've got our x values in the top row and the y values in the bottom row. And when x is equal to 0, which I've circled here, we found that y is 2, therefore that's our y-intercept. The second option, we can visually identify it by looking at a graph. And again, that matches with that right there. So we found that looking at it visually, our y-intercept was 4. We can use coordinates and substitute them into an equation, and we will be looking at an example where that exists. Or we can substitute where x equals 0 into a given equation and solve for y. So again, this is playing into our algebra skills. So probably the one that you're not the most familiar with will be this one here, which is using coordinates and substituting them into an equation. The criteria here may be that you actually have to find the equation. So if we move on to our example here, let's do that. So I'll just change the color of my pen. So we're told to determine the equation of a line given the following coordinates. So we've got where a equals -1, 2 and b equals 2, 8. So on this particular equation, so I've got the matching graph to it. I haven't actually graphed those coordinates, unfortunately. It was a little bit difficult to do. However, you can see that we've got a graphical representation of the equation that we're trying to find. We've got the two coordinates, and let's actually see, we should be able to plot the value. So -1 would be about here. So that would be our a value there, and that would be -1, 2, and b was 2, 8. So there we go. So those are our two values there. I've also actually graphed what we can see here is our y-intercept, and we can actually see our x-intercept as well. And remember that our x-intercept basically exists where y is equal to 0. So it's any time where the graph cuts the x-axis, which is the horizontal. So we've got a few things here now. So what do we need to find the equation? So let's think back to the equation. So y equals mx plus c. We identified in the previous video that m is equal to the gradient and c is equal to the y-intercept. So looking at this, we've actually got our y-intercept. We know that c is equal to 4. Because if we look at where the graph cut the y-axis, it cut it when y was equal to 4. So let's go back and try and find m. Let's even try and prove c using the coordinates that we've been given. We know that what we need to achieve is when c equals 4. So let's do that. So first up, we're going to need to find m. And then second, to find c. So let's do this using algebra. So to find m, let's use the equation y2 minus y1 all on x2 minus x1. You can do the rise over the run method. You can do the y2 minus y1 equals m times x2 minus x1, whatever your preference is. Personally, this is my preference. So let's say that I'm going to use my coordinates -1 and 2 and 2, 8. So we've got m equals 2, 8 minus 2 on 2 minus -1. So that'll give me m equals 6 on, that becomes a plus, so 6 on 3. So m is equal to 2. So I personally like to substitute my values in as I find them. I just find that it stops me from making really careless mistakes. So now that we've found m, let's substitute it into our equation. So y equals 2x plus c. Now, like I said before, because we've actually been given our y-intercept, technically we actually know that our equation will be y equals 2x plus 4. But I want to prove that c equals 4 using one of the coordinates I've been given. So let's say, to find part 2, so that was part 1, we need to now substitute coordinates. Let's substitute coordinate A. Oops, wrong syntax. So let's substitute -1 and 2 and find out if it works. Remember, x is equal to -1 and y is equal to 2. I'm running out of space here, so let's say I've got 2 equals 2 times -1 plus c. So that equals, 2 equals -2 plus c. So bringing that -2 over, I get 2 plus 2 equals c. And I've just found that c equals 4, which actually matches what I've seen on my graph and what I worked out just following the general form. So what I've now found is that c equals 4. I found that m equals 2, and as a result, my equation is y equals 2x plus 4. So what have we found here is that the y-intercept can be found through a few different methods. In this particular example, visually we could see that our y-intercept was 4. Algebraically, we found our y-intercept was 4. And using algebra and our prior knowledge on finding the gradient, we were able to find the gradient, identify the y-intercept, and put them together to create the linear equation. One of the key things I would recommend that you take care to notice is the gradient positive or negative? Looking at the graph here, we can definitely tell that this is a positive gradient because it is going in the positive direction. So just take care to notice of positives and negatives where possible.